Hello friends, today we are going to talk about the arithmetic, computer arithmetic, and how the arithmetic is. Okay, uh, and please pause the video here and listen. You have to get your pen and paper right now, and then only resume the video. Go get pen and paper right now. Otherwise, you won't understand anything. And if you don't understand this, then you won't be able to write anything. So please go get pen and paper right now. I hope you are able to see my screen. Okay, I hope you have your pen and paper. Now let's talk about where the arithmetic functions are performed. What are arithmetic functions? Addition, subtraction, division, multiplication, right? These are your arithmetic functions. Where are these functions performed? In your arithmetic logic unit. Okay, so what happens is your control unit decodes the instructions and converts the instructions into control signals. Then what happens in ALU is only the processing. Okay, only the processing part happens here, not storage part, only the processing part. So from the registers, it gets all the operands which are required for the specified operation. Then it processes those operands. It performs the specified operation by control unit. Control unit specifies which operation should be performed, whether it's addition, subtraction, okay. And then after completion of that operation, ALU returns the result, and that result is stored again in registers. Okay, and there are also some flags. If there are some exceptions, you'll be needing these flags. You'll understand what are exceptions in short future. Now let's talk about how we can represent an integer. First, you need to know that uh, try writing 1, 2, 3, 4, 5, 6. How do you write that? In decimal, right? For 1, you are going to write 1. For 2, you are going to write 2. For 3, you are going to write 3. But because you understand that this is 1, this is 2, this is 3. But in case of computer, your computer doesn't understand this is 1, this is 2, this is 3. What computer understands is a binary language. Okay, that's why we need to understand, first we need to understand how the numbers are converted from decimal to binary. Okay, so the simple formula is 1, 2, 4, 8. Remember that, and those will be the bits. Okay, let's say my number is 4 bits, so I will have only 8. 4, 2 and 1. Okay, because I have 4 bits, it will be 1, 2, 4, 8. If I have 5 bits, it will be 16. If I have 6 bits, it will be 32. And these are actually the positions of bits. Okay, now if I want to represent 1, then my binary number will be it will look like this. There are 6 bits, right? Let's make it 8 bits. 32. Then after 32, it will be 64. After 64, it will be 128. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 bits. If all bits are 0, your number is 0. Now, if you want to represent 1, this last bit should be 1. So, if you want to represent 1, it will be 0, 0, 0, 0, 0, 0, 0, 0, and this will be 1. This is your 1. Now, if you want to represent, let's say 15. Now you have to perform addition on these numbers. 15. Where can you get 15? 8 plus 4, 12, plus 2, 14, plus 1, 15. So all these 4 bits should be 1 and remaining bit should be 0. So this will be, so I'm not going to put space now. You just have to understand the places of these bits. 0, 0, 0, 0, 1, 1, 1, 1. This is your 15. Now you have your pen and paper. Try writing number 55. You have to go through all these numbers. You have to check which gives you addition 55. Represent number 55 in binary. I hope this looks something like this: 0, 0, 1, 1, 0, 1, 1, 1. Okay, so that means 32 plus 16, that will be 48, plus 4, 52, plus 2, 54, and plus 1, 55. Okay, just let's take one more example and we'll go to our next point. Try writing now 75. Write down 75 in binary format. Okay, so I have asked you to write number 75. Okay. So let's see again how we can write 75. This should be 1. This cannot be 1. 60. So again 11 are remaining. So that should be 1, 1, 1. Now put remaining bit as 0, 0, 0, 0. Okay, so this will be your 75. 0, 0, 1, 0, 0, 1, 0, 1, 1. Okay, I hope you have understood how to convert decimal numbers into binary numbers. Now, tell me, how will you represent minus 75? Try writing minus 75. There is no way to know whether it is positive or negative, right? That's why there are two different methods of integer representation, and one of them is sign magnitude representation. So it will be like, and remember, this is your least significant bit, LSB, and this is your most significant bit, MSB. Okay, remember, LSB, MSB, most significant bit, least significant bit. Okay, this is important because your most significant bit will be 1 if your number is negative. Okay, here you can see one example. If this is how you are going to represent 18 by using 8 bits. Okay, 1 0 0 0 1 0 0 1 0. And if you want to represent minus 18, this bit will be 1. Okay, now try to think about the disadvantages about this. So you can only represent up to, there is going to be limitation. You can represent only up to 7 bits now. You cannot use the last bit for representing the number. So by using these 8 bits, how up to 255 you can represent, right? But if you are using sign magnitude representation, this bit will be your sign bit. For sign magnitude representation, this bit will be sign bit. So if you want to represent minus 75, this will be 1, and again remaining will be same as it is. Okay, now try any other number. Let's say 54 and minus 54. Try representing 54 and minus 54. I hope this is right. Okay, so this will be 54, and this will be, if you want to represent minus 54, this will be 1, and then again all the same bits. Okay, so this is the method of integer representation, and its name is sign magnitude representation. I hope you have understood how we can use sign magnitude representation. And another method is two's complement representation. So again, it's like sign magnitude. Two's complement representation uses the most significant bit as a sign bit. So let's go to this numbers. So whatever you can see here, minus 75, minus 54, this is your sign magnitude representation. When will the problem will arise? When you want to represent a bigger number than 64, right? If you want to represent 70, um, sorry, it will be, let's say you want to represent 128. Okay, so this bit will be 1 and all the remaining bits will be 0. So that you can, in that way you can represent plus 128. But if you want to represent minus 128, in that case what you are going to do? So by using this, these 7 bits, you can only represent up to minus 127 to plus 127. I hope that's clear to you. Now let's talk about the 2's complement representation method. 2's complement means what you have to do is take its 1's complement, means invert all these bits. Its 1 complement will be 1's complement is equal to 11110000. Okay, try to understand what I have done here. I have converted all the zeros to ones, all the ones to zeros. Now for calculating 2's complement, the step is add 1 to this. So 2's complement will be equal to 2's complement of this number is equal to, just add 1 to this. So that will be 11110000 and 1. Okay, now what I have just told you, like sign magnitude, 2's complement representation uses the most significant bit as a sign bit. So if this bit is 1, that means the number is negative. If this most significant bit is 1, the number is negative. If this bit is 0, the number will be positive. Again, same scenario in sign magnitude representation. Okay, so in order to need to know whether the number is, what the number is actually, which number is actually represented, you need to know which representation scheme is been used. Okay, now try to calculate 2's complement of this. You can pause the video and calculate 2's complement of this. Which was this number again? 0, 1. I think this was 55, right? So when you calculate 2's complement of this, it will be minus 55, and this is equal to minus 15. So its 1 complement is 11001000. Okay, and if you want to calculate 2's complement, just add 1 to this number. So that will be equal to 11001001. Okay, so this is the 2's complement of this number. Okay, as again you can see the most significant bit is 1. That means this number is negative. So this will be equal to minus 55. I hope you have understood both of these integer representation schemes. You can also calculate 2's complement of 75 and 2's complement of 54. Calculate it now. Pause the video and calculate the 2's complement of this 75 and 54. Try to understand these are two different representation schemes. So based on the representation scheme, you will know which is the number. Okay, the computer will know this is minus 55 only when it is specified that this is represented by using 2's complement representation. Right? If you want to represent minus 55 by using sign magnitude representation, this will be different. Don't get confused. The representation will be different in different types of representations. You will understand it better by after looking at this table. See, we have used 4 bits and these numbers are represented by using 4 bits. So we have represented 0, 1, 2, 3, 4, 5, 6, 7. Okay, and in sign magnitude representation, last bit will be the most significant bit will be your sign bit. So you cannot use that as for representing 8. You cannot represent 8 here. Okay, if you are using 4 bits, you can only represent minus 7 to plus 7 numbers. If you are using 8 bits, you can only represent minus 127 to plus 127 numbers. Okay, so you can see here 0, 1, 2, 3, 4, 5, 6, 7. Okay, and if you want to represent minus, then see here, if you want to represent minus 0, there is a different representation 1, 0, 0, 0, which is a bit confusing because have you heard of sign for 0? There is no sign for 0. That's why this is a bit complicated, and that's why the 2's complement representation scheme was invented. Okay, now you can see here only 1 is appended at only the MSB is taken to MSB is set to 1 in case of sign magnitude representation. Okay, so this will be your 1 कुठे तुमचा, so this is your 1 and this is your minus 1, this is your 2, this is your minus 2. Okay, only 1, the last MSB is made 1. Okay, no other calculations are there. But in case of 2's complement representation, what you have to do is, for this is your plus 1. For minus 1, you have to take its 2's complement. So it will be 1, 1, 1, 0 plus 1, that will be 1, 1, 1, 1. Okay, for 2, its 2's complement will be 1, 1, 0, 1 plus 1, and that will be equal to 1, 1, 1, 0. Okay, you can try calculating all these numbers and how they are represented. See, the values are different in different representations. This is minus 1 in sign magnitude representation, and this is minus 1 in 2's complement representation. Okay, see, the values are different. So which one, when you see some number in binary, which number does it represent? For that you need to know in which representation scheme the number is represented. Okay, so that was all about integer representation. We'll stop here. We will see our next point in our next lecture. Thank you.